Assalamualaikum warahmatullahi wabarakatuh. My name is Rasyiqah Binti Musa, and then my supervisor name is TS Dr. Ahmad Fateh bin Mohamad, and I'm from Fakulti Kejuruteraan Elektrik and Elektronik from Universiti Taman Universiti Malaysia. So my title of this project is to design of a DC optimizer based grid-connected PV system for energy efficiency, home in Taman Universiti, Johor. So for the background, I'm designing a proper sizing of a GCPV system with DC power optimizer. And it was important to ensure good performance and efficiency. So the DC power optimizer, it actually helped the solar system run more efficiency because of I choose one problem about the shading. So for example, if one panel get covered by a shadow, or maybe a panel still cannot work, one of the panel cannot work properly. So the optimizer makes sure the other panels still work in a full of power. So the next one is the significance and impact. The installation of the DC power optimizer significantly enhance the performance of the GCPV system. So this system is translated to home on the receiving consistently better power output for their solar array, and they can maximize the energy generation and escalation their financial return. So maybe this system will low cost their financial. And then the next one is the market potential and commercial viability. So I explain about both of them. For the first one is market potential, high homeowner demand, because of many homeowners want to install the solar to lower their electricity bill and use the cleaner energy. And then the commercial viability is to improve the system performance, because once they know the DC power optimizer can enhance the solar system performance even in the presence of the shade, and to deliver a more power or the full of power. And then the scientific rigor, okay, as you can see that was the location that has been observed with this project, and to get the actual load consumption data at the Taman Universiti, University Malaysia. So here is the table show that the monthly electricity consumption for 1 year, and it's measured in the kilowatt hour, whole year from January to December. So we choose the actual load to do our research or our project. So I'm going to explain about the sizing step about the DC power optimizer. So step 1, we estimate the total number of PV module, and then the step 2, determine the size of the DC power optimizer. And then the step 3 and step 4, as you can see, we calculate the maximum and minimum. Why we need to calculate this maximum and minimum is because of the value of the maximum value is we don't want it the value is higher than the maximum value, and we don't want the value is lower than the minimum value. So we want to set the range. So that's why we calculate the maximum and minimum. And then the step 5 is choose inverter. And then the result is we have 3-step definition of the PV array, sizing the string or central inverter, and last one sizing with the DC optimizer. So the part 1, total number of each constraint, we have 4 constraints. The architecture constraint, we have 56 modules. Energy constraint, we have 7 modules. Budget constraint, we have 10 modules. And the AC power constraint, we have 9 modules. So the sizing of string or the central inverter, the final PV array configuration, we divide into 2 MPPT, MPPT-A and MPPT-B. So the total of the PV module is 7 PV modules. So we divide into 2, 3 for the MPPT-A and 4 modules for the MPPT-B. For the result of sizing of DC power optimizer, step 1, we choose the PV module cycle power 450 watt, and the total number, after we calculate, the total number of PV module is 7 module. So the step 2, determine the size of DC power optimizer. So from the PV solar, we choose the 450 watts. So we choose not more than that range. We choose the DC power optimizer P485 watt, and then the subject maximum PV module in series. After we calculated, we have to go through maximum absolute PV module in series and maximum PV module in series MPT. Both of them we get 2 modules, and then for the minimum we get 1 module. And after that we choose the inverter. So after we calculate, we divide it into 2 strings, 7 module of PV modules. So equal to 7 DC power optimizer. So the string 1 we have 3 units, and string 2 we have 4 units of DC power optimizer. So here is a demo. After we put the DC optimizer on the PV module, the effect. Okay, as you can see, there is the result. So the red line is where we don't put the DC optimizer, and the blue line is after we put the DC optimizer, we generate in the MATLAB software. We put the value here, and then we generate. We want to show the result. And then the intellectual property protection is to safeguard the unique aspect of this research and the practical application. So we plan to pursue a corporate protection. So we cover the original writer material, including research methodology, experiment data, analysis, and conclusion. And then, so I want to show that we already accepted the conference publication. The title of the paper is Optimal Sizing of a Grid-Connected Portable GCPV System with DC Power Optimizer for Residential Application in Taman Universiti, Johor. So we already, the paper we already accepted. We sent the abstract, and then we already do a full paper. So here I will show a bit. And then, thank you. That's all for me. Thank you.